Let's take a look at a really common remote control button that can be used for controlling many things. It could be used for turning lights and fans on, or it can be used for controlling a little doorbell. And the best way to demonstrate this, and I'll zoom down for this, the best way to demonstrate it is to pair it with this. So this doorbell, this hideous doorbell thing, is not currently paired with it. So if I push the button, you can see a little blue glow happening there at the top, but nothing happens. If I press and hold the loudspeaker button in this, until it goes beep, then press this.
Hello, welcome.
It's programmed, so each time I press this now, it will ring this doorbell.
Hello, welcome.
Hideous. It doesn't get any better. It goes through all different languages, and then it just does really long doorbell noises like whole tunes. It's not a good design. There's a reason these were cheap. They won't appeal to many people, but the subject of this video is this button. So let's open this. I should have had the screwdriver ready for this. I really should. Well, let's try just doing it with my hands. This isn't going to work too well. The back cover does unclip to reveal the lithium button cells inside. Is this going to come off? Is it going to come off? No, it's not going to come off, is it? Spudger. Spudger. So where are the clips? The clips are here. Ah, there we go. Inside is a little drawer, and you can pull the drawer out, and it's got 2016 lithium cells in it. If I then unscrew this cover, the reason they get two 2016 lithium cells, that's 20mm diameter by 1.6mm thick, is because they want a higher voltage to increase the range of the key fob. So take these screws out, and this cover plate comes off, and then you can lift the circuit board out. Now, if you're taking yours to bits for any reason, this button just pops right out, and it's got a little bezel that you can get in various colours. This dimple of the bezel, the bit that the LED light shines through, goes into a little recess there. If you don't put it in there, the thing will not go back together properly. And then once you've got that in roughly in that position, this button here actually has a little dimple again that then goes into that because it's designed to have logos on it, like a doorbell logo. But if you're taking yours apart, that is worth knowing. Here's the circuit board. On one side it's got an LED and a button, on the other side it's got a little chip, and that looks like the RF circuitry there. Tell you what, I shall take a picture of this and we can reverse engineer it. One moment please. Reverse engineering is complete. Let's explore. Let's make sure I am focused down onto that. I think I am. So we'll zoom in a little bit and we'll look at the boring side first. Now, if I sound a bit sort of like bunged up and husky at the moment, it's because I've got a cold at the moment. So my apologies if I'm sounding a bit sort of croaky. The back of the circuit board doesn't have an awful lot. It's got the antenna, but notice that the antenna has the layer on either side with plated through holes all the way around, but it stops here. On the other side of the circuit board, there is just literally the bit of antenna missing there where it passes some of the other circuitry. It might be to avoid feedback. We've got the two positive connections of the battery stack, and the reason for the little plastic shroud that holds those cells together is A, to align them up, but also to insulate them so they can't short against the side. We've got the classic button. These buttons are used in many remote controls for vehicles and everything. I see them everywhere. And they are the ones that are prone occasionally to, when you click the button, nothing happens because they seem to be prone to oxidizing inside. And then we get a little blue LED. It isn't always a blue. Some of the other ones have other colours, but it depends on the colour of the bezel. You can get kits for these, or just it's cheaper to buy the whole button, that have different coloured rings around here so they can light up different colours, which seems logical enough. Okay, let's take a look at the other side of the circuit board, which is much more interesting. And I've cropped it down to allow us to zoom in. It just made it easier to reverse engineer. We have an EV1527, which is a classic transmitter chip, and you'd think, well, if it's so common, how come so many products can have them without the risk of one remote control triggering other stuff? Well, apart from this little resistor here, which sets the output data frequency, this chip also has a 20-bit binary value programmed in at manufacturing, which gives effectively well over 1 million different codes. And then you've got another option here that you can set another 16 codes with this 4-bit binary here. There is a very odd arrangement. I'll show you in the schematic. There's a transistor, a PNP transistor, which is basically turning this circuit on, but it's doing so in a very odd way. It's to turn a PNP transistor on, you pull its base negative, and they're doing it in a very strange way through the chip. There's a resistor down here in series with that LED, and then there's a track goes over the output and then triggers this circuitry, which has a transistor oscillator, RF transistor oscillator with a reference that just marked 433, I'm guessing a resonator of some type, and then it's got an amplifier, again based on an RF transistor, and that then goes out to the antenna, which loops round, jumps this bit here, that's the bit I was talking about on the other side, and then just continues on. Okie dokie, let's take a look at the schematic. It's a double-barreled schematic. So we'll start off with the code generator, and I shall zoom down onto this, and then I'll not do what I did last time, focus and actually put it right out of focus. That looks alright, I hope. But here's a power supply, this 2CR2016, and this circuitry here, I think it's just to save quiescent current. It's quite interesting. Here is the transistor that turns the control chip on. And normally, you just basically have codes. It can send multiple codes. So normally you just have a switch that goes to these inputs, and whichever ones were activated, it would then send that code with its other 20-bit code in front of it. To give you an exact value of the codes here, it's 1,048,576 plus the 16 you can set locally. However, in this instance, these all have a pull-down resistor in them, and that means there's a bit of current available. So what they're doing here, here's a standard M6 generic S9015 PNP transistor, and it's got a pull-up resistor to keep it turned off, and then when you push the button, enough current flows through this 47 ohm and the pull-down resistor in here to actually turn that transistor on. I've never seen that before. It's very odd. It took a bit to work out what it was doing. So when it does turn this transistor on, the transistor powers the chip, and it also powers the LED via the 2K resistor. The chip only has one other component. It's got a resistor 300K, which sets I think it's a data rate of 1.66 milliseconds. I don't know if that's per bit, or if that's for the whole packet to be sent. But anyway, the output then goes to the transmitter circuitry, the RF section. So what we've got going over there is just 3 connections, the 6 volts, the 0 volts, and the control for the transmitter. Let's take a look at that. But first of all, I'm going to go and blow my nose because I really am loaded with the code. 1 moment, please. And resume. Ah, yes, I feel so crap today. I'm glad that I'm not doing real work, because climbing a scaffold feeling like this would not be great. Anyway, going over to the other section of the circuitry, we have 2 RF transistors. I should write in what they are. Hold on a second. They are, and they're both the same, R25. There is a big long number for these, but if you type in R25, if you type in R25 RF transistor, you'll find them. They're apparently very common. So here's the output from the control circuitry. We've got a decoupling capacitor here, the output from that control circuitry that is basically turning this oscillator on and off by biasing the base of it up to the positive rail. So it's a 27K resistor, and there is this mysterious little component down here. All it's marked is 433, and 433 megahertz is the operating frequency of this device. You do get other versions, but to be honest, all I do when I go on AliExpress, if I'm looking for remotes, is I type in 433 megahertz, and you'll find all the remote control stuff. But we have that. We've got an inductor, lots of inductors here, on the collector of this transistor, and then we've got a 47 ohm resistor and a capacitor here. This will be really common circuitry to the RF experts, especially with the capacitor coupling from the emitter to the collector, and one coming back for feedback, presumably. Gain, would that be? Yes, think so. But It's basically, this section of the circuitry is being turned on and off, and it's basically a gated oscillator. Then it goes through this capacitor, this inductor, and this is purely an RF amplifier with a pull-down resistor, and then the RF transistor, the inductor, a capacitor to isolate it from the output antenna, and then the antenna itself. And I would say, and that's it. But as we all know, RF technology is black magic. This is very reminiscent of the bugs that I used to make. I went through a fad of making FM microtransmitters when I was young. I stopped doing it when I was in my flat in Glasgow, and I was tuning one in, and you'd tune it until you get feedback, and I was going testing, and I suddenly heard the neighbour downstairs, their radio real loudly go testing, whoop, and it was like, uh-oh, and then decided not to do that anymore. Fun though. But there we have it. These little buttons, very handy little buttons. They're cheap. They just basically throw them in with the receivers, just like you get kits of 1 or 2 of these with the receiver, and they're so common that when you buy a few different RF items, you'll end up with a load of these wee buttons. And they come with a double-sided sticker for the back, so you can stick them in a table, I presume, or at the door. I'm not sure how waterproof they'd be for that, for the doorbell use, or in the wall if you just want to be able to control your lights by just touching a button on the wall without any complicated wiring running everywhere. But there we have it, the generic little radio transmitter buttons. They work very well. They've got a good range, and they're quite interesting inside.